So let's start going through, and again, I'll give you my musings on the note card as well and what I might have on mine. So remember, when we go to simplify, we're going to look at our number first and think about, can I square root it? Can I? Yeah, it's a nice square root. It comes out as what? 7. And then what do I do with my exponents? Divide them. So this will be x squared and y to the 4th. So remember, if there's no index number, that's what we call the little baby number out front. If there's no index number, it's a 2. And so we're going to square root everything inside. So truly square root the coefficient, and then when we square root an exponent, we end up dividing the exponent by the root. 1/2 power is the same as what? Yeah, this also means please square root me. So we have this square root. When you're square rooting a fraction, it seems like, oh, this is going to be really awful. But truly all you're doing is you're square rooting the top and bottom. So almost think of it like 2 separate problems. So let's look at just the top. So if you were square rooting just the numerator, square root of 16 is, square root of y to the 4th is y squared. And then let's square root the bottom. Separate problem, almost. Think about square root of 81, what's that? 9. Square root of x to the 6th, x to the 3rd. Okay, and that'd be my final answer. You always want to double check and see if you can reduce it, right? If it had been 4/8, then I'd have a situation where I'd reduce more. If I had x's in the top and bottom, or both y's in the top and bottom, then I would reduce more, but I don't have any of that going on here. Good? Okay, sliding up. So this is to me, kind of a 3-step process. I'm going to write it up here because I've got a little bit of space. So step number 1 is to isolate the root. And I think we know the word isolate all too well from our experience with COVID and such. Isolate means get it by its lonesome. Now, the root can have stuff under it, but we want the root alone. Like, we don't want anything added or multiplied to it or divided by it, none of that. Okay? Step number 2 is to raise each side to a power, and the power that you raise it to should equal your index number. And remember, the index number is that little baby number in front of the root. So if it's a square root, you would square each side. If it's a cube root, you'd cube each side. So you need to look at what kind of root you have, and then that's going to dictate what power. And then step 3 is going to be to solve for the variable, because step 2 should make that really possible and easy to do. So that's my 3-step process for these. So look at part A. I know it doesn't look like I have a root, but it's there in disguise. What's the root? 3. This is actually saying, please cube root me. So this is the cubed root of 6x plus 16. Now, I want that to be alone. How can I remove this positive 6? Yeah, let's subtract it from both sides. So I'm going to include this in my first step. So this is gone. 10 minus 6 is 4. So again, step 1, get the root by itself. So my root, all alone. Next, I need to raise each side to a power. Usually it's a square, but not in this case. What power do I need this time? 3. So again, in the steps, I didn't say square each side because, again, usually square is the answer, but not always. This time it's a cube because my index number is a 3, so I need to raise each side to the 3rd power. These counteract each other. They undo each other. They are each other's kryptonite. And so now we have 6x plus 16 equals, what do I have on the other side? What? 64. Be careful, because one of my common mistakes that I like to make is I'm like, oh, it's 12, right? 4 times 3. Remember, you've got to raise it. So it's 4 to the 3rd power. can use your calculator for the whole test, so you can use that as support as well. Now we're on to step 3. We just need to solve. How can I get x alone? What would be something helpful? Yeah, let's subtract the 16 first. So I get 6x equals, did I hear 48? Yeah, okay. And then what do I do to finish solving? Divide by 6. X equals, okay. Now, can I plug that back in to double check it and make sure the left and the right side are equal? Yes. We don't need to worry about extraneous roots when it's an odd root, but we do when it's a square root. So we'll be a little bit more careful with part B and C and look and see if they're extraneous roots. All right, let's go to part B. Is the root isolated? Yes. Okay, what power should I raise each side to? 2, because if there's no index number, we know there's a baby 2 hiding there. All right, 8 squared is 64 equals 2x plus 10. So again, these counteract each other. My root is gone because I can't solve for x if it's living under that root. It's not helpful. All right, now I'm on step 3. I just want to solve for the variable. How can I get rid of the plus 10? Subtract it. Remember, we always do the opposite operation. 2x equals 54. Then what? Divide by 2. X equals 27. Let's double check that answer. 2 27s is 54. 54 plus 10 is 64. Is the square root of 64 equal to 8? Yep, so we check out. Questions on A or B so far? Okay. C. What should I do to each side? Square it, because there's nothing with the square root, so we are ready to square. Now, this gives us a little bit of a situation, right? X plus 2 squared isn't x squared plus 4, right? What do we have to do? You have to take x plus 2 and you have to multiply it by itself, so there's some foiling going on there. X times x is x times 2 is 2x. 2 times x. Another 2x. 2 times 2. 4. Okay, let's tidy up this side because I see some like terms. X squared plus 4x plus 4 equals 4 minus 5x. All right, when you have something quadratic, it's quadratic because of this too. So if you have something that's being raised to the second power is your biggest power. If you have something quadratic, do you remember the strategy to solve it? Because it's not linear like the last two, so our strategy changes. Yeah, like get everything on the same side equal to 0. So I'm going to add over the 5x, and because I am an amazing multitasker, I'm also going to subtract the 4. If you don't want to do both in one step, if that's too much and you're worried about making a mistake, do it in 2 separate steps. Okay, on the left, I have x squared. Ooh, now I have a 9x, and what happens to my 4's? They disappear. So, at this point, I have choices. One of my choices is to factor and solve. I could use quadratic formula. I could graph. I could get real wild and go through the process of completing the square. But I think you already know what I'm going to pick. What am I going to pick? Read my mind. Do factor, yes. Sorry, I couldn't tell what you guys were saying at first. It's my old lady ears. Okay, I'm going to pull out an x. Do you see how it's almost a trinomial, but we're missing that term at the end? Okay, so when it's almost a trinomial, oh, I don't know what just happened. When it's almost a trinomial, we can pull out the x, because each have an x, and what am I left with? X plus 9, and all this is set equal to 0. Think back to our friend, the zero product property. if two things multiplied together equal 0, one or the other has to be 0. What would make this 0? 0. Okay, so if x were 0, it would be 0. It's almost so easy of a question, it's confusing. What would make this set of parentheses 0 if x were -9? All right, before I box those in, I want to go back to my original equation. X plus 2 equals the square root of 4 minus 5x. Okay, let's plug in 0 first. If I plug in 0, 0 plus 2 is 2. If I plug in 0 over here, I'll get 4 minus 0, so I'll just have 4. What do we know the square root of 4 is? 2. So 2 equals 2. That's a good day. Let's try the -9. -9 plus 2 is what? Can I get a negative number out of a square root? No. Boom, gone. So this is my only solution. Again, remember that's part of what makes multiple choice questions hard though, right? Like, because you look at it and they're going to be what we call distractor answers. So one of the choices will probably be 0. Another choice will be x equals 9. Another choice will be 0 and -9. So you have to be careful and make sure you know what's going to work and what's not. All right, exponential growth. This is probably where Module 7 truly starts, yes? Okay. So y equals. So I'm going to set both of these up. It doesn't matter what's out front. So remember, we have our initial value out front. Whether it's a population, whether it's money, whatever it is, we have our initial value. So I'm just going to use 500 for both because it can be the same. The out front number doesn't matter. This is always going to be my variable. So it's raised to the x power. What type of number needs to go in a growth problem? A plus. So that at the end of the day, the number that's in here is bigger than 1. So I'll just put 1.5 in. So the number inside the parentheses has to be larger than 1 for it to be growth. For it to be decay, do you remember what type of number has to go in the parentheses? Less than 1, but still bigger than 0. So we're thinking about a number like 0.8. So you're taking 80% of that 500. It could be a fraction. 1/3. Yep.
Like 1 plus.
Yeah, that's fine. Remember, on the test, it's not going to give you the option to write your own answer, right? So you're going to have to look through for the correct answer. So I'd either be looking for something like this, where my growth factor is bigger than 1, or I'd be looking for something with a plus sign. So be on the lookout for either. Same thing here, looking for something in between 0 and 1, or looking for a 1 minus inside the parenthesis. Okay? Are we ready to flip? Yes, no? Yes? Okay, flip. All right. Number 4, part A. Do you see how our bases are the same? So if these things are equal, what do we know about their exponents? They're also going to have to be equal in order to make this a true statement. So I'm going to say 3x plus 1 has to be equal to 15 plus 2x. All right, now, once I'm here, now it doesn't look so bad. Agree? Looks a little less scary. How can I solve for x? Yeah, let's subtract the 2x. I have x plus 1 equals 15. How can I finish solving? Subtract, and I get x equals 14. And again, if we're nervous about our answer, we can go through and plug it back in and make sure it makes both the sides equal. Let's say I get to the test Because remember, testing is a different situation than normal everyday life, right? You've got a little bit extra anxiety. Let's say I get to the test and I'm like, I don't know how to do this one. I don't know why the bells are going off, by the way. Could I work backwards?
Yeah, you can just
Yeah.
plug them.
I could take my solutions and plug them in. Here's the other trick. Let's say you have a list of solutions and you're going to try to plug them in. And let's say A is -3, and let's say B is 0, and let's say C is 5, and D is 7, and E is 9. Let's say those are your values that you have to choose from. This is true for this test, also the SAT, also any other standardized test. Typically, the answers are going to be in numerical order. Start at the middle and plug it in. Does it work or doesn't it work? If it works and then you're done. If it works, or if it doesn't work, and it's too big, then you know to pick one of these two. Do you see how like picking the middle is a good way to go? Okay, make sure you're with me. So pick the middle number first, not because it's usually right. There's no like statistical thing there. Just because that way, if it's too big or too small, you know where to go from there. All right, next one. Ooh, they're not the same Z's, are they? No. And what else sucks is that, do you see how I can't say like, oh, 8 is the same as 4 squared? So there's multiple issues. Let's think smaller though. Is there a number I can take it down to that could be the same base number? 2. So I'm going to rewrite it like this. Do we agree 2 squared will give me back my 4? Yeah. And then my x plus 3 is still going to be outside. Now I have 8. What do I need for my exponent to get back my 8? 2 cubed. We need the third power. Now do I have the same base number sitting there? Yeah. Okay, so a power to a power, what do I do? Multiply. So this is 2 to the 2x plus 6 equals 2 to the 12x minus 24. Now can I treat the problem like part A? Yeah. So let's do the same thing. 2x plus 6 equals 12x minus 24. What might you do to solve? Yeah, subtract the 2x would be my first step as well. Remember, you could do different things first. As long as we're doing it mathematically correctly, we're okay there. What's next? Add the 24. I've run out of room. I'm going to come over here. So I get 30 equals 10x. And then what? Divide. And I get x equals 3. Let me draw a little arrow here. X equals 3. Ooh, good news, I don't need much room for number 5. You need a little room, but not much room. What do we do in this situation with our exponents? So we have the same variable, and they're being multiplied. What do we do with them? Add them, yeah. And remember, always think of a simpler example. If you're like, I have no idea, the fractions, like I can't even look at them, they're throwing me off. Think of a simpler example. If you had x squared times x cubed, what is that? X to the power of 5. Why? Because we added them. Okay, so now use that same mentality here, even though they're a little bit scarier because they're fractions. All right, so common denominator. What would be a good common denominator for me? What? 20. So I'm going to multiply top and bottom by 5, top and bottom by 4. So I get x to the 5 over 20 plus 8 over 20. So I have x to the 13 over 20. If I can reduce, I should, but I can't. Good for that one? We've reached the last one. I'm kind of sad that Susie's not in this problem because I feel like that's a good way to wrap up the year, right? Like, we need a Susie problem. Yes. Anyway, all right, well, pretend it's Susie's boat. 72,000. It's decreasing in value. What should I put in my parentheses? 1 minus. How do I write 14% as a decimal? And for 9 years, yeah? Okay, so let's see what we get. Ooh. Let me go to my calculator. And you should be able to type this in one swoop, whether it's scientific or graphing. I get 18,527.57. Is that what you guys got? You got syntax error. Okay. Have you seen that meme online right now where it's like, this math is easy, and like the person got syntax error and that's what they wrote on their paper?
Yeah.
So like, this math is easy.
Oh, I know.
Why can't people do this? Now
Yeah.
now you got it?
I
Okay.
put-
And not syntax error.